Hello everyone, I am Ayush Kumar of class 9 from Vikas Vidyalaya Dumri Begusrai. Firstly, I am thankful to my institution to give me this golden opportunity to say something about uh, energy. This project is done under Jagrati Rajan sir. Firstly, I explain the topic energy. In fact, I say that energy and mass both are the things which are never be created or not be destroyed in this world. Now we come to our topic energy. Energy. Its definition is the capacity of doing work by a body or an object is known as energy of the body. It means that the capacity of doing work by a body is called energy. In other words, it is also said that energy of the body is defined as its ability of doing work. Second thing, the unit of energy. The SI unit of energy is joule. Joule. Energy is, in fact, we know that energy is equal to the work. The capacity of doing work is known as energy. So the unit of work is also same. The unit of energy. So the unit of energy is joule. And the second thing is form of energy. Forms of energy. First, the mechanical energy. Mechanical energy and sum of kinetic energy and potential energy of a body is known as mechanical energy. Second is sun as a sources of energy. Third is wind as a sources of energy. Sun is a sources of energy. It gives us solar energy. Wind is a sources of energy because the wind have a kinetic energy of wind is known as its wind energy. And third is bioenergy. The chemical energy stored in the biomass is known as bioenergy. Fourth is ocean thermal energy. The energy available due to the difference in temperature of water at the surface and at the deeper level of the ocean is called ocean thermal energy. It means that the upper layer of water, the temperature of upper layer of water and the temperature of lower level of water, the difference between them is known as ocean thermal energy. Now we come to the point mechanical energy. The energy possessed by a body by virtue of its state of rest or the state of motion is called mechanical energy. It have two forms, kinetic energy and potential energy. Firstly, kinetic energy. The energy of a body by virtue of its motion and deformation is called kinetic energy. And the energy which is possessed by the body due to its shape, size, height or configuration is called potential energy. The potential energy have two types, gravitational potential energy and elastic potential energy. Gravitational potential energy is the energy possessed by a body by virtue of its position and above the ground is called gravitational potential energy. Elastic potential energy is the energy possessed by the body due to its deformed state is called elastic potential energy. The formula of the potential energy is derived from here. Firstly, let a body of a mass m be placed at a height h and above the ground level, then the potential energy of the body is equal to the work done. Potential energy of the body is equal to the work done against gravity, equal to the external force into displacement by the external force is equal to the weight of the body. Work done against gravity is equal to external force into displacement by external force is equal to the weight of the body. Therefore the expression for the potential energy is mgh, whereas m stands for mass of the body, g stands for gravitational acceleration due to gravitational, and h stands for height of the object. Now we come to the point expression for the kinetic energy. Expression for the kinetic energy is derived from this way. Firstly, we take an object with mass m and moving with velocity u. It reaches the velocity v after traveling a distance s with external force F. Derived from this equation, now we come to the here. According to the third equation of motion, v square is equal to u square plus 2as. So 2as is equal to v square, s is equal to v square by 2a. W बराबर therefore W बराबर f है. So W is equal to ma into v square by 2a from the equation 1. So W बराबर kinetic energy बराबर half mv square. This and this. And relation between linear momentum and kinetic energy is equal to half mv square. So kinetic energy is equal to half mv square, and multiply m by m in numerator and denominator. So kinetic energy becomes mv का whole square and 2m by 2m. So kinetic energy is equal to p square by 2m, where p is called linear momentum. Now comes into work energy theorem. Work energy theorem says that W बराबर change in kinetic energy. चूँकि W बराबर F है, so W बराबर ma into S, चूँकि F is equal to ma. So W बराबर m into, now here put the value of a and s, so expression becomes W बराबर half mv square minus half mu square, which is equal to the change in kinetic energy. Now comes to law of conservation of energy. According to this law of conservation of energy, energy neither be created nor be destroyed, but can be changed from one form to another. On the starting of this topic, we discussed about it. Now, the law of conservation of energy of a free falling body is: consider a body at height h, at point A, then mechanical energy is equal to potential energy plus kinetic energy. Mechanical energy बराबर इतना, here kinetic energy is 0, so mechanical energy is equal to mgs. When we drop this object from A to B at a distance x, then mechanical energy is here also ma बराबर potential energy plus kinetic energy, but here some kinetic energy is there but less potential energy. So mg into h minus x, this height, mg into h minus x plus half mv square, here putting the value of h. So from third equation of motion, v square is equal to u square plus 2gx. So v square is equal to 2gx. So mg बराबर h minus x plus half m 2gx. It becomes mgh. We see that from first and second equation of motion, mechanical energy is always constant. So we see that all point mechanical energy is always equal to mgh. So energy neither be created nor be destroyed, but can be changed into one form to another. Like here, potential energy, all potential energy is changed into fully kinetic energy after some time. With this, I am ending this topic. Thank you so much.